series with the sigma notation. So let's get into it. Here's part A. Write down the first three terms of the series and evaluate, work out the sum. So people get a little bit confused sometimes with sigma notation, but essentially the variable k appears here. And the idea is we substitute all the integers from this value here, we just add one each time, and we stop when we get to here. So let's just write down the first few. So we have k equals 1, k equals 2, and k equals 3. Put each of those into the expression, and then we actually add them together as well to work out the sum. 2 times 7/5 to the 1 plus 2 times 7/5 squared plus 2 times by 7/5 cubed. So this is u of 1, u of 2, u of 3, and that's the first three terms, and therefore s of 3, the sum of the first three terms, is just all of this added together. Now, there's no need to be fancy here. If we've got a calculator, doc, insert, and just get this, insert a calculator, and actually we have the sigma button built into our calculator. So let's just go and evaluate the sum. It's next to the number 9. You've got a little menu with key features, key functions, and we just get this one out onto the screen. And we just type in exactly what we see, and this is k equals 1. Over here we get 2 times by open up the fraction button, keep things nicely aligned, and that's 7/5. Looks like the laptop's being a bit slow here. 7 here and 5 here, but the 7/5 is in a bracket, so make sure we get that in a bracket, and then this is powered up to k. And we want the sum of the first three, so k is 1, k is 2, k is 3, and we just go ahead and evaluate it. And there's the answer. We can write it down like this, 1526 over 125. The calculator gives an exact answer, or we can bring this down here and press Control equals, and we will get the answer as a decimal, which is equal to 12.208. I'll just check down here under menu, not under menu, under document. Let's try that. Document, settings and status. Let's see how my calculator is rounding off answers. Document settings. Okay, so this is the full exact answer. Float means it's going to give me at least 15, I believe. I think it's 15 significant figures. So that's 12.208 is not rounded to 3 decimal places or 5 sig fig. That is the exact answer. Okay, state whether the series is arithmetic or geometric. Well, you can probably see, can't you, as you move from one term to the other, I mean, what's happening? Can you see it's got an extra 7/5? So it's actually r equals to 7/5. This is part B. So this is definitely geometric. Alright then, so let's move on to the last part, which is here. Find how many terms are needed for the sum to exceed 1 times 10 to the 6. Well, look, we can go back to here and see that the first term is 2 times 7/5 to the 1, so that's 14/5. We know that r equals 7/5, and we want the sum to exceed 1 times 10 to the 6. So I'm actually going to do this in 2 different ways, but each way will rely on a calculator solution. You might like to think if there's a way of getting towards an algebra solution for these, and there may well be, and then maybe we'll do the algebra solution as a third option. But the first option is using the summation formula. Okay, and this is over r minus 1. So let's substitute everything in. U of 1 is 14/5 times by r, 7/5. It's power of n, and then subtract 1. And on the bottom, I'm going to do r minus 1 altogether. So 7/5 minus 1 is 2/5. Okay, so there's the summation. 14 fifths divided by 2 fifths is actually 7, so this simplifies to 7 into 7 fifths to the n minus 1. And we need that to be bigger than, let me just get a little bit more space here, than that space really, bigger than 1 times 10 to the 6. So actually, we can do this quite algebraically with logarithms. Maybe I'll say that till later. But first I'll try it with a graph. So go back to your TI Nspire. I'm going to type in the left-hand side of this, which is 7 times by open bracket fraction 7 over 5 within the fraction here, 7 over 5. This is to the power of n. It's in a function. We'll change that n into an x. And then just press the right arrow because this is minus 1, is back down on the normal level. When we draw a graph of that, there it is. But we're also in control T, the table of values. And so this is so useful for sequence and series because all we have to do now is just keep going down until we find 1 times 10 to the 6. And it seems like it'll take a long time, but it won't. We'll get there before you know it. And can you see we're already there? So it looks like it takes 36 terms. So basically you're just going to write down S of 36 equals to 1.28 million times 10 to the 6. We'll just write down S of 35 just as a comparison, and that's 911,268. Therefore, we need 35 terms. Okay, you can see that. If we carry on from this particular spot here, let's just go do this in an algebraic way. So let's just copy this. Let's put another page in afterwards. Let's paste it. Now you can see that n is just in one location, so we should be able to unpack this, shouldn't we? 7 over 5 to the n minus 1 is greater than 1 times 10 to the 6 over 7. And then 7 to the 5 over 5 to the n is greater than 1 times 10 to the 6 over 7 plus 1. So therefore, log base 7 fifths of 1 times 10 to the 6 over 7 plus 1. We're going to change this to an equals here. Strange things happen with inequalities and exponents and logarithms. We're just going to do this here, and we're going to just put equals to n, and then we'll interpret the final value once we've got it. So let's go back to page 2 here. Let's just try and type that in as a logarithm to see if it will work. Now our logarithm button is above here, above the 10 to the x, so there's the log. And in the base here we are going to put a fraction. So let us choose a fraction for the base. 7 fifths as a base, 7 over 5. And then in here this is 1 times 10 to the 6, this is just 10 to the 6. Okay, and that number there is divided by 7, and then we plus 1, and we should just get our answer there. So that looks quite familiar, doesn't it? N equals 35.3, and you know that this exponential is increasing, so we need n equals 36 is the integer solution we need, which matches our answer here. Oh, look at that, I made a little mistake in the previous question. N equals 35 was incorrect. It needs to be n equals to 36 because we clearly need 36 terms to go above 1 million. So good job we checked and did it a second way. Now that's a little mistake. But then actually there is one way which is even cleaner. Let's see if this works. We've got sigma k equals 1 to n here. We've got 2 times by 7 fifths to the k. Now this is the formula for the sum up to n terms. We want that to be actually bigger than 1 times 10 to the 6. Now if I rearrange this, if I do k equals 1, 2 times 7 over 5 to the k here, if I choose n here, I do minus 1 times 10 to the 6. and I put a little equal 0 again. I'm going to see if I can solve this equation using the calculator. Now the calculator just wants you to do one tiny change here. I'm going to change this up to a K, and let's see what happens. So on here, I'm going to go menu, I'm going to do algebra, and I'm going to do a numerical solve. So we're going to type this in and see what the calculator can do for us. So let's go to a sigma notation from our menu here. I'm going to do this guy here. Actually, if I press escape, I could just go back up and copy it from previously. So let's see if we can go and copy this guy here. Might be a bit quicker. Yeah, my laptop's slowing down a bit because it is. Alright then, so I want k equals 1 up to k. 2 digit there. Okay, that looks good. And then I need to subtract 1 times 10 to the 6. I didn't get the power there. Exponent of 6. And then equals 0. So I've got the equation equals 0. Now I need to solve comma for variable k. Let's see if this would like to work. Ah, look at that. And notice it gives us exactly k equals 36 on nsolve. So nsolve is a really useful tool. Nsolve will only ever give you one solution, however. So if you're trying to solve a quadratic using nsolve, quadratics sometimes have 2 solutions, right? Or a cubic, 3 solutions, then nsolve probably isn't the right way to go. But for an equation where you know there's just one solution, and you're using technology, then nsolve is a great tool to use. I mean, look, even when we use the laws of logarithms and kind of solve this algebraically on this page, you can see, can't you, that we still had to reach the calculator anyway. So, I mean, what's the difference? Maybe we just go straight for this nsolve. We know what we're doing. We set up the equation. We use the calculator efficiently. We get the right answer.